Hello, everyone. Welcome to today's webinar, Spandrel Panels, a Challenge for Code Compliance. My name is Twyla Neely-Strite, and I'm the Education and Operations Associate at Illinois Green Alliance. You've all been muted upon entry, so please type any questions you have into the Q&A, and we'll get them answered at the end. And this webinar is being recorded and will be sent out to you in a follow-up email. For those who are unfamiliar, Illinois Green Alliance is a membership-driven nonprofit organization that advances green buildings and sustainable communities for all. Our 5-year strategic plan pushes the green building industry to meet or get on the path to net zero. We achieve this work through education events such as panels and building tours, by engaging communities and partnering with organizations across Illinois, and by advocating for new policies and legislation. Members can view our recorded webinars on our on-demand webinar library on our website. You can also learn more about membership, see upcoming events, and get involved by visiting our website, illinoisgreenalliance.org. And I also want to take a moment to recognize Illinois Green Alliance's sustaining sponsors who make our work possible. A special thank you to our gold level sponsors, ComEd, Resource Innovations, Sloan, and USGBC. Make a commitment to advancing green buildings and communities across the state. Start a conversation about sponsor partnership today at illinoisgreenalliance.org/sponsorship. And now on to the main event. We have a great lineup of speakers for today's program. We'll be hearing from Ana Gabriela Alvarez and Khadija Nesbitt. Ana is an architect with a master's degree in engineering or energy engineering. She currently works as building performance analyst at Database Plus within dbHMS. Her work is centered in improving building energy efficiency and performance. Khadija's interest in building enclosures and building sciences led her to a career as a building enclosure commissioning provider 5 years ago. Having had the opportunity to commission enclosures on a multitude of projects across the building sectors, she's had many experiences that have taught and aided her in resolving enclosure-related issues and challenges alongside her peers and project team members. Khadija continues to support project teams in producing functional and high-quality enclosures in her current role, believing that doing so sets a strong foundation for high-performing buildings. And after we hear from our speakers, we'll have an audience Q&A led by my colleague, Katie Kaluzny. And now I'm going to hand things over to our speakers to get us started.
Good afternoon, everyone. So today we will be talking about spandrel panels, a big problem or a challenge for code compliance. You can go ahead and move forward, Gabby. We already did our introductions, so I think you guys already know who we are. Gabby, do you want to go over the agenda?
Yeah, first we'll talk about what is spandrel panels, then we'll be talking about what is the issue with the spandrel panels and code compliance, what are challenges in design, then we'll talk about what are the challenges during construction, and at the end we'll do what are some solutions we can find.
So first, we're going to start with what is a spandrel panel? So a spandrel panel is an opaque portion of a glazing system used to conceal building elements. So they're typically at floor slabs, at ceiling elements, insulation, anything that you do not want to see on the exterior, but you still want the appearance of glazing on the exterior. So you're hiding something from the interior, you want something on the exterior. So in general, there are multiple types of spandrel panels, but the one of two main types for a standard system would be a glass spandrel with an opacifying coating, so something that limits the transparency of the glass, or you could have a shadow box spandrel, and which is what we're going to primarily focus on today for this discussion. Spandrel panels, well, typically they include glazing. You can also have other materials besides the glass for the exterior facing So you could have metal panels, which is one of the more common ones, but you have many options. So in terms of a shadow box spandrel, saddle box spandrels are composed primarily of a transparent glass with a metal backing. They may or may not have insulation, and it allows more visual depth than other types of spandrel panels. Saddle box spandrels are integrated into the metal framing of the glazing system. So they have the same reduction of performance due to the frame, even if there's insulation, similar to like a metal framed cavity wall.
And now we'll talk about what's the issue with spandrel panels and code compliance. And first of all, we will be talking about 2022 Chicago Energy Transformation Code for commercial buildings. So here in the image, you could see the different paths for code compliance, and we will be talking about ASHRAE 90.1 energy cost budget. This is a performance path that uses simulation software to calculate the whole building annual energy cost. This we will call proposed, and that is relative to a simulated code minimum building that we will be calling baseline. That said, here we have a table from ASHRAE 90.1 2019, Climate Zone 5A. This is for Chicago, and we can see that this categorizes building envelopes into opaque and vision. And we could see that we have the opaque elements and non-residential and for residential, and we have different types of walls, and then we have fenestration, and we'll have the different windows. So the standard panels, being opaque elements, have to comply with the values of steel frame, which is an R value of 20. But standard panels, even if we add insulation to comply with these values, if we take into account the effects of the frames, we will find it hard to exceed a value of R5. And for that, we've made this graph where you could see on the x-axis the Spandrel nominal R value, and on the y-axis you will see the Spandrel panel effective R value. So this Spandrel panel effective R value is the R value taking into account the effects of the frame. This should be calculated within the NFRC 100 and the NFRC simulation manual. But when you do this, like you could see the Spandrel nominal R values don't get further or bigger or greater than R5. Like the R20 as nominal Spandrel panel could be really an R5, very far away from our code that is up to R20. So this is our first and big challenge, trying to comply with code. And also we have to take a look into the aspect ratio of the Spandrel panel, because this also takes into the effective R value, since like we did this graph to kind of explain. And in the x-axis, you could see the Spandrel panel aspect ratio, and you'll see this is all of them are Spandrel panels with R15 and the same area, but changing the aspect ratio of the Spandrel panel. So in the x-axis, if you see to the right, the value of 1, that is a square Spandrel panel. So the height and the width are the same length. And as we change the aspect ratio, our Spandrel panel gets wider and shorter. And this is also what a lot of Spandrel panels tend to be like, starting to get wider. And on the y-axis, you'll see the Spandrel panel effective R value. This is taking into account the effects of the frame. So if you see the R value, it gets even lower, getting farther away as we make it like decreasing the aspect ratio, and we could see it gets even farther away from code, from the baseline that we're calling here. And this, adding to all of this, there's also an indirect issue with the window to wall ratio. So here also we could see that code that requires us up to 40% window to wall ratio. The window to wall ratio is a portion of the building envelope that is constituted by windows. So if we have an window to wall ratio of 40, this is the part of the envelope that is made up of windows. And this is important because when we are trying to do curtain walls with Spandrel panels, we probably have a window to wall ratio greater than 40%. So we're trying, like this line, this blue line represents our proposed building. This is our building, and we could be increasing our window to wall ratio as we want to do it in our building. And we'll see the code, the baseline, is also increasing its window to wall ratio, but up to 40%. And in the y-axis, we have the envelope U value. This is the U value of the whole envelope, taking into account the opaque part and the vision. And we could see that even if we have a better performance in our proposed, as we increase the window to wall ratio, then we will have to compare it with the baseline. We'll have to do better than the baseline. And this is going to be hard when we are increasing the window to wall ratio up even into an 80%. And these are all the challenges we have to face trying to comply. Now we'll talk a little bit about what are the challenges in design and that we've encountered. And this is an office building in Chicago, and this is a window submittal from the contractor, and we were having trouble defining the values. And we see that we were very lucky to have input from the contractor since the beginning, because we usually don't. This is something that at the very early stage of design, we don't know the impact of the Spandrel panel will have in our building. So even though we had this input here, we could see that first we have, I'll explain a little bit of this chart, and we have the area of the vision and the area of the spandrel, and we have a base system, and then we have this same base system but adding 3-inch of continuous insulation. So we have same area for, this is for a curtain wall, so that's why we have the vision and we have the spandrel and we have the overall, and then we have the U factor, and we'll have the vision and we have the spandrel U factor and the overall. And you could see marked in red for the baseline, we had a 0.18 U value. And with the adding insulation, we have a 0.05. So this insulation is behind the panel and also behind the frame. But we could see that even like it looks like a great improvement, because we're taking an R5.5 to an R20 in the spandrel panel. But at the end, the overall, it just changed from 0.31 U factor to 0.28. This is an R value of 3.22 to an R value of 3.57, which is at the end not much. So this is the challenges we face every day, trying to have a good performance in our envelope. And even if we take this 0.05, this is an R value of 20 for the Spandrel panel, but we just saw that this is very hard to achieve. So we even question ourselves, is this 0.05 really taking into account the frame, we could even question ourselves, like, this could be even performing worse. And also something that we question a lot to ourselves is that these values are usually given from the center of the panel. But what happens, like, when you get closer to the frame, that it's going to perform worse because of the being near to the frame. So we question ourselves, even, is it fair to use these values? Is it fair to use the values that they are giving us? Is these values that I am talking about, the energy modeling standpoint? And is it really these values that sometimes are given to us fair? Is it taking into account the framing? That's something that we usually don't have much information about. And we also wanted to talk, this is an other project, totally different project, and this is another point we wanted to make. So this is a mixed use development, and we wanted to show the impact of the curtain wall system using the performance path, like in the impact that it has in the whole energy model. And this is the whole building. So I'll explain a little bit this graph because I know it has so many things in it. And the second bar, you could see at the left, this is our baseline. And we're comparing the energy cost budget for the whole building. And you see the red dotted line, that is our baseline. We have to do better than this. And all the other bars is our proposed building, but we're simulating and changing some properties of the envelope. This is also a building that had a lot of curtain wall, so a lot of windows. And what we can change is the window to wall ratio. We can change the solar heating coefficient, and we can change the U value. So we did all of these options, and we could see that overall, we are performing better than the baseline. We are performing better than the code. And all these colors are the different components of the building. And you could see that we have the cooling, we have lightnings, we have heating. But at the end, we're passing code because we can take into account the whole building. And the envelope we have, which is not great, we have to compensate that with a very effective HVAC system, for example. And this is the way that we are passing code. Like, we're not looking at the envelope, and we are compensating that with our other systems. So this is like what we do, and this is, I think it's great. But what happens if we take a closer look at how our building is performing, how our envelope even is performing? So in this graph, you'll see the same. We have also the baseline at the left, the second bar, and the different rounds, these are the same. And we have a dotted line on the positive, and we have another one in the negative. The positive is heat addition, and the negative is heat removal. So we'll see that at the end, taking a closer look, all these options of our proposed are even being worse than baseline when we are looking at the loads on the envelopes, on the building, sorry. And so we're looking at equipment, we're looking at infiltration, we're looking at lights, we're even looking at people, and we are looking at the loads that we have from the envelope and from the windows. And we could see that most of it is doing worse in the envelope. So at the end, we wanted to say, okay, we're passing code, that's good. And we have great systems, but do we want to take a closer look to our envelopes, to what our envelopes are doing to the performance of the building? Like really take a look at it and trying to, and knowing that we can do better, that we could do even better than what we are doing.
So in thinking about, because we were asking the question, when you looking at isolating, just looking at the envelope performance, what happens and what we can do, and kind of how this impacts the overall project. We start looking at some of the design impacts for spandrel panels during construction. So the idea is that to get the optimal performance out of the spandrel panels, which we're highlighting the struggles of getting that R20 that would be necessary. How the spandrel panels are designed and installed is key. So if we want them to perform even as good as they can already, we need to make sure we're installing them and designing them properly. So some of the issues that we're trying to prevent, we're starting with condensation. So when it comes to spandrel panels, we get condensation when warm air bypasses that back pan of the spandrel panel and enters into the shadow box. And then that interior glass surface would reach the dew point and cause condensation. So the condensation will then be visible on the exterior, but then it can also cause damage and staining, especially as if we have issues with our weakening our seals, moisture getting in between each surface of the insulating glazing unit. And then sometimes this moisture that gets in our spandrel panels on the interior, we see them and we think, oh, there's a leak somewhere. There's a leak with how things are in the installations and how things are installed, how the whole system is installed. There's a leak somewhere in our building, when really it's actually the condensation that was produced from the spandrel panels or from the curtain wall system itself. So this is something that we want to make sure that we're thinking about and we're trying to prevent, because that's only going to cause us more issues later on down the road for our enclosures. If you go to the next slide, Gabby. So another thing that we have to, there we go. Another thing that we're looking at are hotspots. So it's uneven heat distribution across the glass can create uneven stress distribution on the glass. So get hotspots. So where we have these uneven stresses, you can cause glass breakage and then damage to our coatings, such as our low E coatings. And then there's also pressure and temperature differential issues that are handled by the curtain wall manufacturer and the glazing supplier that do impact the system and need to be considered when developing our spandrel panels. Next slide. In general, when we're doing construction, of course, there's going to be debris, dust, materials, spills that happen during the construction projects, and these can contaminate or accumulate on the interior spandrel surface. And then once the building is getting ready to be turned over, we're trying to button everything up and get it ready for substantial completion. We're looking and we're seeing all of this construction dirt on the interior of our spandrel panel, and now it's visible on the exterior. But even sometimes these chemicals, they can damage the glass and be difficult to clean and remove without making any further damage. This creates like an aesthetic concern. And then because of how the spandrel panels are installed, you have glazing lubricants that can be left behind in the spandrel panel that are not properly removed and leave deposits. And then any sealants or paints within the shadow box contain volatiles that can be released because of the solar gain that happens within the spandrel panels. It's extremely warm in there, and it can exceed 140 to 160 degrees Fahrenheit. So these volatiles can condense on the glass and then additionally cause damage and aesthetic issues. So there's a lot of different factors that we have to consider with spandrel panels, especially because of how they're constructed, and we need to make considerations prior to as we're in the design phase, and then also once we're out on the construction site. Next slide, Gab. So as I mentioned, some of these items that we're concerned about can be addressed during your design phase, right? So there will be spandrel panels, shadow box spandrels that are called out in the design, but like they're not shown as being sealed vapor tight. So these notes, having these notes in your drawings and having them in your specifications and pinpointing that importance when they're installing the spandrel panels is one way to help to address these from the design side. There's also a way to design shadow boxes with vented air cavities to prevent the condensation that can occur within the shadow box. When it comes to the glazing, using heat strengthened glass for the exterior light of the insulating glazing unit, and then tempered glass for the interior light to reduce breakage due to thermal stress. And then the overall makeup of the insulating glazing unit, the spandrel, the makeup of the spandrel, and the installation actually on site, they all have an impact of the performance of the spandrel. So it's all tied together in order for us to get a system that works properly for the life of the building. Also, shadow boxes need to be sealed properly to maintain the air and vapor control layers. So they're part of the primary air and vapor control areas of the building. So we have to treat them in that same exact way and making sure that we're sealing them properly. A lot of times, some of the insulation that's used for spandrel panels are foil backs insulation. And they'll be taped and sealed at that the back panel on the back side of the spandrel panel. And how those are installed, it's very important that those are installed properly and there's not tears and rips that will allow for things like warm air to bypass the metal back panel of the spandrel panel. So we have to treat the spandrel panels as part of the air and vapor control layers, and just like how we make it a serious issue to make sure we're maintaining continuity for the building and the enclosure in general, we want to include the spandrel panels in that and not just consider them as separate or isolated. I will say that this detail that you see here to the right is an anchored detail, but there will also have to be considerations for any spandrel panels at moving conditions. So the design has to take in account for any movement as well. So it's not a one size fits all. So of course, everything is project specific, but we have to make different considerations as it relates to maintaining the air vapor barrier control layers, especially when I have moving conditions. Calling this out clearly in design documents can aid in proper installation, both in the drawings and in the specifications, and adding language to kind of fortify and boost the drawings and specifications as it relates to spandrel panels, kind of tie this all in together so that we have sort of a snowball effect when we get out onto the project during construction, that they have the tools to be more successful and take these into consideration. One aspect of it, once we're on site and we're installing these panels, is that shadow boxes should be completed entirely once they're started. So meaning the installation, if there is any back pan, seals, everything in place before moving on to the next section of work. Anytime we leave anything open or like work in progress for something that's eventually supposed to be sealed off, we run into those issues of somehow not sealing it properly, or running into the issues of getting that debris, construction dirt, and causing there to be issues later on down the road. So having these discussions will be key during your pre-install meetings when we go over our major systems, bringing up these comments, asking them about quality control documentation, installation checklists, daily logs, photo documentation of installation, and the installed work. But along with this, regular site visits to review how the installation is taking place and what we're seeing even before the building is finished, to catch any issues. And this part of this is, there's site visits the architects perform themselves, but also building enclosure commissioning providers, as well as building enclosure consultants, having regular site visits to kind of see the progression of the installation, and making sure it's matching the contract documents and calling out issues is another way to combat some of the challenges that we have with spandrel panels during construction.
And now, what are some solutions? And first of all, be very, very clear. Be very clear about the need to account for the frame. And this is, I feel like, very important. Like spandrel panels have frames, and we have to take them into account in our calculations. Also, a high recommendation is to follow the NFRC 100 and NFRC simulation manual. And I'm not expert on this, but we do have experts on our firm, and there are a lot of experts in the field. And let's call to them. Let's bring them on. Let's help us find the correct value for our spandrel panels. Also, underscore the impact of the window to wall ratio on the performance. Spandrel panels are usually part of a quartering wall system, and increasing the window to wall ratio of our buildings have a high impact in our performance when we look closer to it. Also, call out the assumptions in any target value shared with the client, shared with the design. What are the assumptions we are taking? Where are these values taken from? And very important, having these conversations get us closer to a solution. This that we're doing right now, all of us, we are building a solution. We're talking about it. We're taking a closer look about it. We're getting like all into this theme, and this is actually a solution, which is getting us closer to a solution. Also, a standardized way to calculate our value of Spandrel panels, so the designers can make more informed decisions. And yeah.
Yeah, I can speak to these ones, but also to add to having these conversations that get closer to a solution. The point of the presentation is not saying that there is 100% solution currently. It's that this is something that we are talking about, we're having, that has become a difficulty factor. It's been known, the challenges have been known, but a lot of times because we can get the building to fall under code, or we can get the building to work and move forward with the project, we're not getting a chance to stop and really look at what we can do to make it so that we can calculate our value of spandrel panels, and really to understand the impact that a spandrel panel and how it's insulated or not insulated will have on the building. And so that's really just to add to what she's already said about the design, is that this process of going through and figuring out how we can better approach this is what starting conversations really will help us to do, because there's not a set answer and we don't have all of the calculators established yet. But the more we talk about it being an issue, the more we can get towards that, instead of just pushing through and saying, okay, it's fine, because, you know, we're still able to move forward on projects. But another thing is hiring, from the construction side, hiring a building closure commissioning provider earlier rather than later. A lot of people think commissioning providers, they come at the end to see how the work is being installed. But a commissioning provider is really there for the life of the building, from the start until the end, and even after the substantial completion of the building and turnover. And having a chance to have a commissioning provider that can help provide recommendations, suggestions, and point things out, and be a second pair of eyes for the project team during your design phase, during your specifications, and during the drawing phases, to construction document phases, to be able to kind of highlight and start these discussions, and also help to articulate some of the challenges and the why we need to be paying attention to these items. But then also fortifying the design documentation to clearly identify the intended expectations. So a lot of times, we'll have spandrel panels and they'll be, written into the specs, into the drawings, but there's not anything talking about sealing it vapor tight, or even considerations for, the condensation that could potentially happen if we don't pay attention to how we install our the foil back insulation and taped it and sealed it. These conversations, they know they need to install the system, but the attention to detail gets kind of lost in translation. And so then we'll have issues later, and we go back and review and like, oh, well, if we had done X, we wouldn't have had Y happened. So I think that's part of that we're finding, is some of that in the design documentation, the more clearly it's articulated, that helps to mitigate some of these issues out into the field. But then also a discussion and quality control with the project team during construction. So just highlighting, how are these being installed, notifying, documenting any issues or deviations from contract documents, any concerns, what is the quality of the installation? Because what might be look okay now, later on, as we have different temperature changes, the building continues to progress in time, what doesn't go well during construction will then be a maintenance issue for our owners. And so how much can we address now instead of later, when we have all of our interior finishes up, and you have to do a deep dive investigation as to how to solve a problem, resolve an issue. So the sooner we can have these conversations when we do have spandrel panels on projects with our construction team and kind of combined alongside with the design team, the better that it will be for the client and for the buildings in general and the performance of the buildings moving forward.
Awesome. Thank you, Gabby and Khadija. It was an awesome presentation. You have a lot of questions that have come into the Q&A. And so I hope you are ready to keep talking about spandrels and solutions. Thanks again for everybody for joining. I'm Katie Klusny with Illinois Green Alliance. Excited to dig into some of these questions here. So the first question that came in was right at the beginning of your presentation. So you may have addressed it throughout, but I'm going to reiterate the question here and see if you want to take a stab at this one. But the first question was, are energy models for glass buildings all fundamentally flawed, or there are some that have some tools or calculators that you found that do take all this into consideration?
I'd say they could be better. Windows are always important. They for lighting, for ventilation, and I mean, it's to find the balance between window to wall ratio what will makes us get a better performance from our building. So yeah, well, that would be my answer.
Oh, you're muted.
I definitely pressed the unmute button. My mouse is against it. So just to add to that, and there, because we have the spandrel panels, we have heat buildup within our spandrel panels that doesn't get accounted for, like what happens within essentially this enclosed space that is facing the sun. And so to get more information about those, you'd have to do more of a project-specific finite element analysis for the heat gain that's happening, the heat buildup that's happening within the spandrel panel. So it's like there's more analyses that need to be done that are project-specific that I think would happen in that earlier stage of design, and that be another resource and a tool for Gabby's team, or people on Gabby's team, to be able to provide a better energy model. So I think it just needs to extra consideration, extra thought to be put into it, not just here are the values that we're giving you, but an actual analysis specific to the spandrel panels to sort of fortify and give the energy models more information.
Thank you. There's another question regarding the ASHRAE table that you shared during the presentation, asking about how do the requirements for the clear glazing compare with the spandrel section requirements?
The mute button is fighting with both of us, Gabby.
Oh, you're pulling back up the table? Oh, you're muted though, Gabby.
Oh, I wanted to share the slide again, but I think I did something else.
No worries.
Just to look at it.
I can see the slides now if you want to go backwards.
Yeah, I'm trying to go backwards. This one, right?
Yes.
So we have opaque elements and we have fenestration, and sometimes it's actually a great question to say, like, are spandrel panels opaque, or could we count them as fenestration even though they are opaque, right? But it's actually not none of them. So answering your question, like windows, you could see you have the U value, the solar heat gain coefficient, and the visible transmittance. So spandrel panels won't have this because they are opaque. So we cannot put them in fenestration, and that's the difference on fenestration and opaque. So it actually fits a little bit better in opaque, and we take them into the steel frame values in this table.
It
Thank
fits
you.
in opaque. If it fits in opaque, Gabby, like what they're saying, but our issue is that it doesn't function like how you can get an opaque wall to have continuous insulation and get the R values that we're looking for, right?
Yes.
Mhm.
Stan, if you have follow-up to that question, feel free and add it to the chat or to the Q&A, and we'll make sure that we dig into that further if you needed more. I have a question from Lauren, a couple actually. One asking in the window to wall ratio plot. So if you want to go back to that slide too, what do the orange and blue lines represent?
Yeah, thank you. I feel like maybe a little explanation here would have been better, but the blue line, that's our proposed. That's the building that we are designing, and the orange line, that's the baseline from code. And we from when we're using this path of compliance, we have to do better than the baseline, and we're increasing as we could have any window to wall ratio we have, and we'll be comparing it to the same window to wall ratio in the baseline. But when we get to 40%, if we go like after 40% more window to wall ratio for our building, we will have to compare it always against a 40% window to wall ratio. For the baseline, that's the maximum window to wall ratio. And this is where it hurts on us trying to make a better performance than code, because you see the blue line, the U value of the envelope will continue going increasing, right? So this will be very hard to meet.
Makes sense. Thank you. And then in the slide with the infrared image, there's a question about why is there a huge wall of green, presumably not leaking much heat? Can you give us a visible light image of the building from the same angle? Maybe we can't do that now, but can you share or share a little bit of information on this one?
So this portion onto the left there isn't actually the opaque wall. So this is the glaze. This is all glazing and spandrel panels on the right. I did not take this image, so I don't. I can pull. I have the original image. I can share that after the fact. But there is actually an opaque portion of the building is to the left. So when they took the image, that's why you can see all of the framing here.
So it's not leaking, is what she's asking. That portion. So that portion of the building is not leaking heat. That's what her question is.
Oh no, so there's a temperature graph, it's in Celsius on the side. So it's not that it's leaking heat, that the way that the infrared is reading it, it's reading it, if you look at the color ranges, the lowest being dark purples being towards 4.7 Celsius, and the reds being closer to 26.7 Celsius. So it's not that don't think of it as in terms of leaking heat, it's that is how it's registering on the infrared image. So you can see the opaque portion is registering at a lower temperature than the framing, which is metal, the metal framing here. So this is a cladded system on the left, and then the metal framing here is that because it's a sunny day. Well, it's a sunny day. So your metal framing is getting closer to those higher temperatures, the upper range of the temperature scale on the right-hand side of the image, and your opaque wall are is getting close towards the below the 26.7 Celsius. So there's still heat, it's just the amount it's not, amount is the wrong word to use, but there's just different levels to it. But you can see based off of the scale that the framing is hotter in that sense than the opaque wall to the right, to the left of it.
I just want to share, there's a note in the chat also about this image is a good example of how the spandrel framing puts holes for heat to escape around the center of the pane. If you want to speak to that, just while we're still on this image.
I'm reading all the chat messages too. It's a good point. May also be due to reflection from cooler areas. But I also, and I don't want to open up a can of worms, but I don't want to think of it, and there's a temperature scale that's given, but we don't want to think of it as heat in the sense, when it comes to an infrared image. And so there's also different factors, right? So the reflectivity of a surface. Notice this photo is not taken head on at the building, it's taken at an angle. So there's multiple factors that go into an infrared image. But I also would say that what it's showing you is that when you're looking at where the spandrel panels are, or how much more heat is concentrated there versus on the other surfaces of the building, even though it's all the same face of the building. I feel like there's more and more comments and stuff coming in.
No worries. I have a few more questions, so I can keep going and we can circle back to this one if we have time. Is that okay?
Mm-hmm. Yeah.
So there was a question about if you've had a discussion or if there's time for a discussion on vented versus non-vented and foil versus metal back pans in those scenarios that you were sharing near the end of the presentation.
So to speak to the foil versus, you can go back one, Gabby. Go back one. Yeah, foil. So what I'm talking about is the metal back pan that's in place. So I'm talking about foil. You have foil face insulation, and to as part of that system, that foil acts as your vapor barrier. As part of that system, there's tape to go along with it. And so if there's to seal off the areas so that we have vapor control at the metal back pan. So you'd still have a metal back pan, but to continue on that vapor barrier, they're going to install, like, they might have a tape to go along with their foil back insulation in order to do it. So you're still going to have your metal back pan at the back there, but you, as part of depending on what insulation you have in there, you're going to have the accessories to go with it to continue to create that vapor barrier and have it continued throughout, have it to be continuous for the building. So it's not necessarily that you would have your back pan would be foil. It's that you'd have your back pan, you're sealing off to make your continue your vapor barrier. So however if your insulation is foil back, you would have the tape to go with the insulation. If you have a different type of insulation, you'd have sealant joints at that metal back pan to seal off and create that vapor control. So it depends on what insulation you're using and what will be required to maintain that vapor control. I hope that answers that person's questions. It's weird not being
Steve,
able
feel
to
free and write it in the chat if you want to follow up on that one. He has a follow-up question kind of related, and there's some words in his question that I don't know. I've not read before, so sorry in advance if I ask them wrong. Have you done modeling with fiberglass spacers on the mullions and the impact those have on the performance of spandrel areas? And if you want to get back, we can answer that question in a follow-up document to attendees, but just sharing in case you have that off the top of your head.
Gabby, let's get toward you, Gabby.
Yeah, I think we could circle back in this one because I don't feel like I could answer it.
No worries. Steve, you're stumping the panel. So keep asking more questions. And then I have a question about how do you, or if you, collaborate with glazing manufacturers to reduce on-site issues on spandrel areas?
Well, so you have in the specifications what the recommendation is for what the contractor is going to procure for the glazing for their system, right? So you're already getting specifications for that glazing. And so you're basically asking the glazing manufacturers questions. Each product has a different specification for what it's supposed to perform and how it's supposed to work and function. And so you can collaborate them in terms of asking questions or to figure out how to best present options for the contractor to procure for their project. So for example, we mentioned that for spandrel glass, we want the exterior lights to be heat strengthened, and then we want the interior light to be tempered, and tempered is much stronger than heat strengthened. So if I'm submitting and saying I want these insulating glazing units to be used, right, each of those have specifications and they submit product data. And when you're reviewing this, you're looking at what each light, what kind of glass is being used for each light. And then you're saying, well, this is going to be installed for my spandrel panel. Is this going to be sufficient for the purpose that I'm trying to use it for? So this is why, as part of like commissioning providers, we also help in reviewing those project submittals. So when I get project data, I'm comparing it to my specifications, and I'm seeing, okay, well, this glazing will be used for a spandrel panel, but this one is, I don't know, maybe it's monolithic glass, or maybe there's not heat strengthened. It's maybe the back interior light isn't tempered. And so this is something I would call out, like, yes, we said we wanted to use this glazing. This is provided by the contractor. They're saying they're going to use this product. Now I'm looking at the specifications and I'm understanding that this spandrel will be installed. This particular material may not be the best for this project. So it's not so much collaborating as if like you're telling a glazing manufacturer how to install their system or how to produce their glass. It's more so you receive information on the performance of their glazing from manufacturers. You ask them the questions of what each light is, a type of, whether it's heat strengthened or tempered for each light, how does that function in their insulated glazing unit, and then take that information and ask yourself the question, is this going to work for my project? And sometimes sometimes their product data, I've had really great product data that gives me a lot of information, and then I've had product data that gives me almost nothing that really can help me in terms of making an informed decision as to whether or not this product is suitable for what I know the design team wants for the building. And so sometimes that means you're calling them and asking the questions to get more information that maybe wasn't clear on their product data. So it's more, that's one way. And you do this, during the submittal phase, during the design phase of, we're suggesting that this product for this application, is this going to function? So it's really having a conversation, not asking them to call and change their products and give us something different.
Thank you. And I'll just add, there's a comment in the chat back to, maybe it's just to the host and panelists, back to the previous question that's kind of related to this one, about the foil-faced insulation. And so what Steve was mentioning is he was driving it using foil-faced insulation with a vented spandrel area, and that in a recent project, they were able to head off an issue where this was the case and a design flaw by the manufacturer.
Foil face with a vented cavity.
Foil-faced insulation with vented spandrel areas. If you want to read the comment, it's in the chat, not the Q&A.
Multiple.
Yes, vented cavity, he said. But just sharing, because it's related to both.
Got it. I see.
Conversations.
Yeah, I see what you're saying. So they had a vented cavity and they want to use foil face insulation. This goes back to this goes back to consider reviewing the design and then includes what the intent is, and then understanding what material is going to work best for that system. So if that's, I probably end up circling around back to this question, but it's in terms of, that's why it's so important to look at this during design, right? So maybe you've already had a potential panel that had foil face backing and used it for a different project, and maybe it's unvented, and you left it alone and you move forward and it worked out fine, there was no issues. But then you try to copy and paste for each project, and we have to consider some of the changes in our systems and changes to our details that needs to be had. So you have to use the right insulation, the right glazing, and have designed or have included in your design the right spandrel and right cavity in order to have a successful spandrel panel installation, right? So it's not a one size fits all. What works for one might not work for other, just like how some buildings, there's certain designs for buildings in warmer climates versus colder climates. So I can circle back with you, but it really comes down to if we're going to have a vented cavity, what insulation are we going to use? If we're going to not have vented cavity, how are we going to maintain the vapor barrier? And if we're going to have a vapor barrier that has foil face and is using tape to maintain it, how are we going to protect it so it doesn't tear? So all these different things are factored in. So it's like you have to ask like a snowball effect question. This is what we have, this is how we're going to implement it.
Awesome, thank you. This one is kind of half question, half statement. So I'll read it and you guys can decide what you want to do with it. This one is, are you aware of an addendum to 90.1 2019 that requires a baseline envelope performance factor before you can trade off mechanical equipment? Saying this should encourage investment in long-term quality envelopes.
I think it would really encourage for taking into a better close look into the envelope before trading into any HVAC system.
Awesome. And then I just have a question, and I know we have to wrap up in a second here, about how do building code officials interpret the classification of the spandrel areas of curtain wall?
Sorry, say that one more time. I was
Sure.
reading the other questions.
No worries. How do building code officials interpret the classification of spandrel areas curtain wall?
So which parts are a spandrel, right?
Mhm.
No, the opaque parts are a spandrel and the vision is the glass.
So is there any additional building code official interpretation of those items to be aware of? I think that's what the question's getting at.
I think they're not for the perspective first for the path. I'll show you. Well, sorry, but I'll say there is not like a specification of where will all, I don't know all of the codes, but where will the spandrel panels fall in are usually taken into account as opaque surfaces, but sometimes it's not officially said that the spandrel panels are opaque in all of the codes. It's not usually stated in.
That's great. Thank you so much. I know that we are at time, and there are a few more questions in the Q&A and in the chat that we didn't quite get to. So I'm going to follow up with both of you, Gabby and Khadija, and along with Twyla. We'll send any additional questions that didn't get answered to our speakers to help us answer those for a follow-up email for everyone. But just want to thank you both so much for your time and presenting this topic today. The challenges and potential solutions associated with it. Really appreciate your insight and input into this, this issue. For everyone on the call, we will send a follow-up email that has a recording of this session, along with a PDF of the presentation from the panelists, that at follow-up Q&A. And if you have any additional questions for our speakers, feel free and send them our way, respond to info@illinoisgreenalliance.org, and we will get those on to our panelists. Thank you all again, and have a really wonderful afternoon.
Thank you, speakers. Thank you, everyone. Have a great day.